Alright, so after we have seen the pre-order traversal, post-order traversal, and in-order traversal, let's have a look at the binary tree level order traversal. So that is problem 102. So for this problem, we first go through the statement of the problem, and then we look at example 1, then share the shortcode. So the statement says that given the root of a binary tree, so we are required to return the level order traversal of its node values. In other words, from left to right and level by level. So let's have a look at the typical example 1. So the first level is 3, so we're going to have a 3 in the output, and then the next level is level 1, so we have 9 and 20, so we have another list consists of 9 and 20. So the level 2 or third level, so we have 15 and 7, so we get 15 and 7. So the total output is a list consists of 3 lists, and the 3 lists corresponding to each level. So that's example 1. So example 2 is sort of simple, and example 3 is a special case. And the constraints says that there are about less or equal than 2000 nodes, and the second constraint is about node value. So with that said, let's look at the method. So first, when we write code, we want to mention one point. So the point is that, so when we do the pre-order traversal, in-order traversal, and post-order traversal, so the data structure involved in our format of writing is the stack. So here, when we do the level order traversal, so it's like the breadth first traversal of a general graph. So the data structure involved is actually the queue. So this is one point we want to mention. So here we want to write a very formatted or brute force way for this problem. First, I'm going to do some initialization. So I'm going to initialize a result, which is an empty list. We're going to first also check the special case. So if not root, I'm going to return the result. So this is step 1. The second step is basically the iteration. So when we do the iteration, I'm going to initialize a queue. At the very beginning, it consists of one node, that is the root itself, because we have already excluded the case that the node is null. So now we have a non-empty queue. Then we do the while loop. While queue is okay. So what we want to do is that we add the current values of the queue to the result. So in other words, we want result append. So let me do a list comprehension. So for the node value for node in the current state of the queue. Then we get here. Then we are going to update the state of the queue. So for example, you can imagine currently we are here, then we want to go to the next level. So for this, I'm going to use a list comprehension again. So for clarity, I'm introducing a temporary variable. So for this, I'm going to extract all the child. So child for node in current queue and for child in the left or right of the node we are looking at. So for child in, so node left and node right. So this tuple consists of the right order. So we need to first look at the left, then look at the right. So also we want to add a filter, that is, if the child is not null. So by this way, we get a state for the next iteration for the queue. Then we just need to reset the state of queue. So actually we can directly set Q to be this long thing here. But for clarity, I introduced a temporary variable. So with that said, so if finally Q is empty, we didn't add anything to the result. So with that said, we are ready to return the result. So we're going to return a result. So each of the Q state corresponding to one level. So actually, this code can be easily modified to get how deep or what's the depth of the tree, right? So with that said, let me first test a special case. It passes the example 1. So now let's look at the generic case. Yeah, it passes the generic case. Actually, if we want to see the procedure, actually, we can print out each of the levels. So print, let's see, let's copy this one. Print this guy. So let's run the code. So this is the first in the standard out. So this is the first level, that is 3. The second level is 9, 20, and the third level is 15 and 7. So with that said, that's about it for this problem. So actually, you are encouraged to explore more applications of this piece of code. Thank you.